Alright, so welcome to this lesson. We are continuing chemistry. Okay, so we've done most of the stoichiometry part. We've done the units, the measurements, the conversions, all that we've done. Okay, so now we are moving into what we call as solution stoichiometry. Okay, so we are going to be dealing with a lot of concentrations. There will be moles, there will be volumes, okay, something like that. That's what we're going to be dealing with here. Okay, so we'll be looking at solutions and concentrations in this video. Okay, so these are the objectives, okay, that we have to achieve by the end of the lesson. We have to know what a solution is, what a solvent and a solute are. We can also discuss water as a universal solvent, okay, and then we look at some electrolytes. Okay, we have strong electrolytes, we also have the weak ones. Okay, and then we can look at concentrations. Okay, so here I wrote in different units. All these units here can be used to measure concentrations. Okay, but in this video we are specifically going to concentrate on this one here. Okay, these others we can talk about them another day. And then we'll look at dilutions, okay, and the formula to use when you're diluting. Okay, so this one here I'll be more of teaching and less of the solving today. Okay, and then we'll have another day where we'll have more of the solving. All right, so that's how we are going to move in this lesson. Okay, so on my next slide here you can see I wrote what is a solution. Okay, so a solution is a mixture of two things. Okay, so the first one is the solute, and then the other one is the solvent. Okay, so the solvent is the liquid part of the solution, and then the solute is the the solid part of the solution. So for example, if you have water in this cup, okay, you have water in this cup, and then you put in sugar like that. Okay, so that sugar that you're putting in there is a solute, okay, because it will dissolve in this water that you have put here. So this water that you have put there will be what we are calling as a solvent. Okay, so when you combine a solute and a solvent, you form what we call as a solution. Okay, so a solution is simply a mixture, okay, of a solute and a solvent, and I've given you an example there. All right, so moving on, we can now talk about water as a universal solvent. Okay, so from the previous slide we know that a solvent is where the solute is going to dissolve, right? So the liquid where the solute is going to dissolve, okay, that's the solvent. So water acts as a universal solvent. Okay, why? Because it is capable of dissolving a large variety of substances. Okay, so a lot of things that you can have when you put them in water. Okay, when you put them in water, they will be able to dissolve in the water. Okay, when you put sugar, it will dissolve. When you put salt, it will dissolve. Okay, so there are a range of values of things that can dissolve in water. Okay, so there is no other any liquid that is known that has the capabilities of water. Okay, so we refer to water as the universal solvent here, okay, because it is capable of dissolving a large variety of of substances. Okay, so water is defined as a universal solvent, okay, based on the polarity of the molecule. So polarity simply means that if I have one molecule here, this same molecule here will have a positive charge on one side, and then it will have a negative charge on the other, like that. Okay, so these will be slightly positive, slightly negative charges. Okay, so if I have a molecule, and then on that molecule I have two, okay, I have two charges. The other part is behaving as if it's negative, the other part is behaving as if it's positive. Then we say that that molecule is polar. Okay, so water in its nature is a polar molecule. I don't know if you've learned this in biology yet. Okay, so what happens in water is this. So we know that water is written as H2O. Okay, so meaning this oxygen here is bonded to what? Two hydrogens. So you can see the illustration here. I have the oxygen here which is being bonded to what? To two hydrogens, like that. So what happens is that this oxygen is more electronegative than the hydrogen. Okay, so electronegative simply means the ability of an atom to attract um, electrons to itself. Okay, so what will happen is that, because remember, when you're forming water, this is a covalent bond between the hydrogen and the oxygen there. So we know that in the covalent bond we have the sharing of electrons, so it can be something like this, and then you are sharing to my electrons per cut, right? Okay, so because this oxygen is more electronegative than the hydrogen, it will try to steal all these two electrons that these two elements are sharing. Okay, it will pull them to its side. So when this oxygen now is pulling the electrons this side, okay, even that side, what happens is that we have a large concentration of a negative charge on the oxygen because it's pulling electrons like that. Okay, and then what remains on the hydrogen is a slightly positive charge like that. So because of this nature of water, okay, it has a positive on the other side it's negative. Okay, it will behave as a very good solvent to many substances. Okay, so that's why water is a universal solvent. Okay, so I wrote the notes here for you. These notes are there on Drive, so you can check them out. Okay, but I've explained the basics of what this means here. All right, so universal solvent, you can see here. Okay, so in that water, if this is the water here, okay, and then you have those polarity happening, okay, it means we have some sides, okay, that will be more positive, and then some regions that will have more negative. Okay, so if you dissolve something like sodium chloride, which is table salt, okay, we know that sodium chloride, when you dissolve it in water, it's going to form sodium ions plus chloride ions. Okay, so these chloride ions here, they will go and be around these negative charges because they are positive. Okay, and then these negative charges here, they will go and be around these positive charges here. Okay, so there is this kind of interaction that happens. So you can see these red things that I put here, and then you have sodium carry positive inside there. Okay, so these red dots here are what? Negatively charged. Okay, and then we have these green ones. Okay, the green ones here represent the chlorine ion. Okay, and it will be surrounded by other parts of the water that are what? Positively charged like that. Okay, so that's what it means to be polar. So because of this attribute, water is a very good solvent. All right, so what happens when you put chemicals in water? Okay, so what happens when you put chemicals in water is that they will either dissolve. Okay, let me use dissociate. Okay, they will either dissociate completely or they will dissociate partially. Okay, so those that dissociate partially are called as weak electrolytes, and then those that dissociate completely are called as strong electrolytes. Okay, so we can now look at these electrolytes. Okay, so electrolytes are just simply ions. Okay, they're just simply ions. So you can see here magnesium, this is the chloride ion, this is the potassium. Okay, so this is what electrolytes are. So electrolytes are formed when, okay, so to answer that question, I'm going to read this. Okay, so here I was saying, what is an electrolyte? So any substance that produces ions, okay, when dissolved in a solvent, and this solvent 100%, okay, most of the time is usually water. When this substance dissolved in water is called a what? An electrolyte. So if you get anything and then you put it in water, okay, and then that thing dissolves, we're going to call that as an electrolyte. Okay, all right, so we have three types of electrolytes. Okay, we have those strong electrolytes like sodium chloride. When I put sodium chloride in water, I'm going to get a fully ionized solution like this. Okay, meaning these atoms here, okay, will separate completely and they form ions like that. And then we have some that are weak. For example, if I have this H and then I have COOH, okay, so when I dissociate this guy in water, okay, only this one hydrogen, this one here, separates from the rest. So we are going to have H plus, and then we are going to have plus CH3 COO minus, like that. So we can see that we still have three H's in this formula. Okay, so here it means that this one here does not dissociate completely. Okay, it does dissociate partially because we're only forming one hydrogen ion, but we have four hydrogens in the chemical formula. Okay, and then we have non-electrolytes. Okay, for example, like glucose, water, sugar. Okay, when you dissolve this sugar in water, nothing will happen. Okay, it will just remain the way it is. It will just be sugar. Okay, it won't dissociate into two ions. No. Okay, it will just remain the way it is. Alright, so that is a non-electrolyte because it does not form any ions. Okay, and then moving on, we can talk about what? Okay, we can now talk about okay, so here I was showing the types. Okay, so strong electrolytes are usually from strong acid, okay, like the hydrochloric acid, the sulfuric acid. Okay, from these types of acids here we get strong electrolytes, and strong base like sodium hydroxide. Okay, we also get strong electrolytes even from the salts. Okay, the example that we gave, okay, this sodium chloride. And then the weak electrolytes here, we get them from the weak acid. So that guy that I gave an example here, and then COOH. So this one here is a weak acid, so it will produce a weak electrolyte. Okay, and then we also have some weak bases like ammonia, just like that. Okay, so from there we get weak electrolytes. All right, so here I have an example now of a strong electrolyte and a weak electrolyte. Okay, so a strong electrolyte example, I've used the hydrochloric acid. So when we dissolve this hydrochloric acid in water, okay, it's going to form hydrogen ions and chloride ions. So we can see that there is total separation of these atoms here. So this is a strong electrolyte. Okay, and then on the weak electrolytes, okay, we can see that this Hc2 H3O2, okay, when it dissociates, only one of the hydrogen here separates from the rest. The rest remains intact like that. So it means here the dissociation is not complete. So this one here is a weak electrolyte. Alright, so it's very important to understand, okay, the weak electrolytes and the strong electrolytes. So if you have any questions, please feel free to ask as I explain. Okay, so here I even gave an example of a question. I'm saying fill in the blanks. Okay, aqueous sodium chloride, okay, can be described as, okay, so the answer there is a strong electrolyte, because if I put this sodium here, if I dissolve it in water, okay, it's going to give me sodium ions and chlorine ions. Okay, so this one here is a strong electrolyte. But here you can see now the example that I gave of glucose. Okay, so glucose is a non-electrolyte because when you dissolve it in water, okay, it will just change the state from solid, it will become aqueous. That's all. Okay, it won't separate like that. So it's a non-electrolyte because it does not form what? Ions. It does not form ions. Alright, and then now we can talk about the important thing, okay, when we are dealing with solutions. The most important thing there is the concentration. Okay, and the concentration that we are going to be dealing with here will be the concentration of what? Moles. Okay, so the concentration of moles has a special name. Okay, we call it as the molarity. Okay, so throughout your chemistry, okay, molarity will be very, very important. Okay, when we are talking about the acid-base titrations, we have the simple ones, bulk ones, the redox titrations. Okay, you will be using what? The concentration in moles, which is the molarity. Okay, so it's very important to understand this concept. Okay, so molar concentration, also known as molarity, let me write it like that. Okay, so it is defined as the number of moles of solute in 1 liter of a solution. Okay, so this here is the standard measure of concentration in chemistry. Okay, it's the standard measure of concentration in chemistry. We are going to be defining the concentration in moles, okay, and volume. All right, so how do we find the molar concentration, or how do we find the molarity? Okay, we divide the moles divided by the what? The volume. Okay, so you'll be given the moles, you'll be given the volume. When you divide them, you find what? The concentration. Okay, and that concentration we are going to call it as molar concentration. So in symbols, the formula looks like this. Okay, so here where they see, I shouldn't put C here because this is the molar concentration. Okay, so it should be M, capital letter M. This means molar concentration is equals to number of moles divided by what? Volume. So now there's an important aspect that we should take note of whenever we are finding the molar concentration. Okay, we have to make sure that the units for this N are moles, and we have to make sure that the units for this volume are liters, okay, or cubic deci meters, like that. Okay, so always when you are given a question that involves molarity, and then you are given unless when you are doing the additions, okay, there it doesn't matter, but anywhere else when you are given a volume that is not in liters, okay, so for example they can give you maybe 200 milliliters, make sure that you convert this volume to liters before you do anything. Okay, and they like that, they always bring these units in milliliters. Okay, so these milliliters are the same as the cubic centimeters, so they can bring like that or they can bring like that. Always convert your units to what? To liters before you do anything involving molar concentration. Alright, so from this formula we can get another formula for finding moles. Remember the one that we've been using, it was moles is equals to mass over molar mass. You remember this formula, right? So here when we're dealing with molar concentration, we're given an opportunity to work with another formula for finding moles. So we are going to say moles is equals to, and then we just cross multiply, so it will be molar concentration multiplied by volume. Okay, so this here is the new formula that we are going to be using to find what? The moles. Okay, so moles is just equals to mv. All right, so I've explained there, and then this was still the definition. All right, and then we have a problem sample here. Okay, so they're saying what is the molarity of 0.4 moles of sodium chloride dissolved in 0.250 liter of water. Okay, so the molarity will just be equals to the moles 0.4, and then we are dividing this by the volume 0.250. Okay, so when we divide this, we're going to get 6.1, I mean 1.6, okay, moles per liter. Okay, so now there's another important aspect that you should know here. These moles per liter here are the same as the capital letter M. Okay, so when you're given a concentration maybe 1.6 m, just know that this m here, if it's a capital letter, okay, it means moles per what? Per liter, or moles per cubic decimeter, like that. Okay, so don't get confused there. So this m here is the same as moles per liter, so they can give you anything here. Okay, so that first example. Let's look at another example here. So in this example, saying a saline solution contains 0.9 grams, okay, of sodium chloride dissolved in 100 milliliters of the solution. What is the molar concentration? So notice that we have milliliters there, so we have to convert these to liters. So what do you do to convert the volume to liters? You get your milliliters, okay, you divide them by 1000. So it means your liters here will just be 0.1 liters. Okay, and then once you have your volume, strive to get the moles. So here we've not been given the direct moles. We've not been given the direct moles. We've been given the mass instead of this sodium chloride. Okay, so we know that the moles will just be equals to the mass over the molar mass. Okay, so the molar mass of this, you add is it 23, okay, 23 point something, and then plus 35.45, okay, you should get something like 58.44. Okay, so 58.44, that's the molar mass of sodium chloride. So we are going to divide with it, 58.44, and then you just punch that onto your calculator. Okay, we are going to get what? We are going to get 0.0154 moles. Okay, and then once we have our moles and we also have our volume, we can find our concentration. So we are going to say concentration. Okay, I was finding it here for you. Concentration is equals to, I can put the moles on top, volume down. That is my answer there. All right, so any questions there on the molar concentration? Any questions? All right, so I'll continue since there are no questions. Okay, so this is another question. You can check it out in the notes. Um, okay, so we have them here. It's almost similar to the one I solved. So you have the mass of the sodium chloride in grams. So we need to convert these to moles. Okay, and then once you convert to moles, you can divide it by the volume. So notice that the volume is in liters here. So we have no problem. Okay, we can just find the concentration. Okay, so the concentration will be what will be the molarity? Okay, so we have 58.44 grams divided by, what did we say was the molar mass of this? It was this same thing, right? If I can go back here, the molar mass was 58.44. Okay, so 58.44, we're going to divide it. So this first part here is just my moles. So this is my mass, and then this is my molar mass, and then I'm dividing this by my volume. Okay, so we see that this one is going to give us 1. So it means molarity is going to be 1 over 2, which is just 0.5 molar, okay, or moles per liter. So that's how we find the concentration there. Okay, so next we look at yet another example. Okay, so here I'm saying calculate the molarity of a 25.0 grams of KBr. Okay, so we just have to know the the molar mass, okay, of that KBr there. KBr. So the molar mass of KBr, you have to go to your periodic table and then you check um, uh, the molar mass of potassium and the molar mass of bromine, and then you add them. So the molar mass of potassium is about 39.0 39.1, if I should say, okay, and then that for bromine is about 79.90. Okay, so you add that, you are going to get this. Okay, so the molar mass, the mean star will be about 119.0 0.00 grams per mole. Okay, so this is the molar mass of this KBr. So we are going to say moles is equals to 25 divided by 119.00 is equals to. So what are we going to get there? Okay, so you get your calculator and then you punch your value. So 25 divided by 119.00. So we're going to get about 0.21008. Okay, so these will be the moles, and then we notice that this volume here is in milliliters, so we have to change it into what? Into liters. So we divide by 1000 here, so it's going to give me 0.75 liters. Okay, so to find our molarity, we're going to say this is equals to the moles divided by the liters, so 0.75. Okay, So whatever we are going to find here will be our answer. Okay, so let's do that. So 0.21008 divided by 0.75. So we are going to get our molarity approximately 0.28, okay, just to two decimal places, moles per liter. Okay, so it's very simple. So I'm giving you a lot of question here so that you it can go into your mind, okay, that you really need to know how to find this molarity, okay, in case they have given you millimeters there, okay, I mean milliliters there, and then in case they have given you grams. Okay, so once we know this, and then the other things will be very simple. Okay, the other things will be very simple. All right, so that's it about the concentration. Okay, and then okay, do I want to talk about the mole fraction? Okay, I'll talk about this in another video. Okay, and I want to talk about the dilution formula. Okay, so dilution, we know that it's just adding water, right? Okay, so if for example what I have there is juice, okay, if this is juice, I can get some water and then I pour here, okay, to dilute this juice. So dilution is just the process of adding water, okay, or we can say dilution is the process of adding more solvent, okay, while keeping the solute constant. Okay, so you can see here the solute is in higher concentration. You can see a lot of red stuff there, right? So the solute is in higher concentration. That's why the juice is sweet. And then when you in water like that, okay, you start pouring water like that, okay, these particles here, okay, they will now be in lower concentration, okay, and the volume will increase like that. So if the volume increase, the sweetness will reduce. It means there is now a what, a lower concentration like that. So you can just see countable to my red things there. Okay, so that's what it means to dilute. It just means to add water. Okay, so the important thing to know about the dilution, okay, and dilution formula is that the number of moles before and after dilution is the same. Okay, so the number of moles doesn't change. What changes is the volume. Okay, the volume is the one that changes, and the concentration, but the number of moles doesn't change. So remember we said molarity was equals to moles over volume. Okay, so if we make moles the subject, it will be mv. So when you're dealing with dilutions, okay, this value, the mv, does not change. Okay, so mv simply means moles. So the number of moles do not change. What changes is the concentration and the volume, but the number of moles, okay, is the same in the sweet juice, even in the juice that is not sweet. Okay, the number of moles will always be the same. So we are going to base our dilution formula on that. Okay, so we are going to say the concentration, I mean the moles before dilution, okay, is equals to the moles after dilution. Okay, so that is the formula that we are going to be using when we are finding the when you are using the dilution formula. Okay, so these are notes. Okay, so let's solve an example here. So this is an example on dilution. Okay, an example of dilution. Oh, someone is saying, did you start the recording? Yes, it's recording on top here. You can see it, right? Okay, so the question is, how would you prepare a 225 milliliter of 0.15 molar calcium nitrate solution if you have 2 liters of a 2.0 molar calcium nitrate solution available? Okay, so whenever you see such question where they're saying how can you prepare, just know that the dilution formula. Okay, so the dilution formula states that m1 v1 is equals to m2 v2. Okay, so this m1 v1 is number of moles before dilution is equals to the number of moles after dilution. Okay, so how do you get the m1 and this m2 v2? Okay, So the concentration and the volume that you have before you dilute are your M1 and V1, and then the ones that you get after dilution are your M2 and your V2. Okay, so that's what we are going to be using there. Okay, so in this case, okay, we are saying how would you prepare. Okay, so this solution here is not yet there, we want to prepare it. So this one here will be our M2 and our V2. So our M2 will be equals to 0.15 molar. Our V2, okay, is equals to 525 milliliters.
Doing you just work like that. Okay, whatever units you are given, just work like that. Okay, there's no need to change. But for these other things that we'll be doing, we have to change the units to what? To liters. Okay, and then what is our V1? Okay, what is our V1? So our V1 here is actually unknown. Okay, because we have a lot of this calcium solution. Okay, and then from that 2 liter calcium solution, we want to prepare, okay, okay, so we're going to say the volume, okay, the first volume is not an is unknown. Okay, and then the molar concentration here, which is the M1, we know it is equals to what? 2.0 molar. So to find how we would prepare this solution, it means we need to find how much the volume of this, okay, we need to have. So we are going to say M1, which is 2, multiplied by V1 is equals to M2, which is 0.15, multiplied by 525. Okay, so it means V1 is just going to be equals to, so you get your calculator and then you punch 0.15 divided by 525, and then we are dividing that number, let me put it in brackets, we're dividing that number by 2. Okay, so when I divide that, I'm getting 0.0057. Okay, let me just leave it here. So this are milliliters like that. Okay, so once you found your V1, okay, once you found our V1, you can now find how much water, okay, was added to this V1 in order for it to have a volume of. So let us do that now. Okay. My calculator is misbehaving. Okay, solutions. What's happening? Concentrations.
Okay, I think let me do the multiplication again. Why am I finding that number? So it's not possible here. Okay, let me do the calculation again. So I have 0.15 multiplied by 525. And then I divide by 2. So I was wondering, the calculator gave me a wrong answer here. So this one here is not correct. So let's find. So first of all, 2v1 is equals to, and then we multiply this by 525 like that. Okay, so when I multiply by 55, I'm going to get 78.